In this video, we're going to be answering these same 5 questions about this third example. This is going to be the most challenging one because this one requires the product rule, and then for that second part of the product rule, it's going to require the chain rule. So the first step of finding the first derivative is going to just take a little more time than it did with the other 2 examples. But let's jump right in there. All right, here's my u. Here's my v. I'm going to find each of those separately. So u is just x, means u prime is going to be just 1. V is not so simple. So v is going to be 2x plus 1 to the 2/3, and I'm going to leave this as a fraction exponent. I'm not going to change it into like a cube root and a quantity squared. That would be more trouble than it's worth. To find the derivative, bring down the 2/3, keep the inside the same, subtract 1 from it gives me a negative 1/3, then I'm going to multiply by the derivative of the inside. Now, when I clean this up a little bit, this is in the numerator, this will be in the numerator, everything else will be in the denominator. So this will be v prime is 4 over 3 2x plus 1 to the 1/3 power. Now I'm going to put it all together with the product rule. So y prime will be u times the derivative of v. And I'm going to be really clear about what's on the top and what's on the bottom. So that x that came from the u part, that's in the numerator. Then plus, I also want to be really clear about where my plus sign is so I can see where I need a common denominator. Let's see, v times the derivative of u is just a times 1, so we can kind of leave that part off if you choose to. All right, so now I need a common denominator. The denominator that I have over here, that's the common denominator I'm going to try to get, so I'm just going to copy it. But if I do that, I've also got to multiply by that on the top as well. And remember, that's just this second term that I'm multiplying by that. The first term, it's got the denominator it needs, so it stays the way it is. All right, so now this is a 4x in my first term. Combine those 2 things in the numerator. And then I'm copying this exactly the way it is, 1/3. And now this term has the denominator that I need now. I've got a 1 that's really not important. I've got a 3, so I'm going to put that out in front. And then here's the other neat thing about this. This parentheses to the 2/3 power, and then this same parentheses to the 1/3 power. Well, that's exactly the same as if I had like an a to the 2/3 times a to the 1/3. You've got the same base, so you can add the exponents. So we're going to do that. Same base, add the exponents. 2/3 times 1/3 gives you a power of 1. So this cleans up very nicely. And then in my next step, I'm combining, since I have a common denominator right now. Let's do one little thing here. Distribute this, it becomes 6x plus 3. So that'll make it easier to combine like terms. 4x plus 6x gives me the 10x, and then plus 3 in my numerator. This is my first derivative. Well, it took a little more work than it took in the other examples, but if you've been practicing, it should be no big deal. The next thing we're going to do is find critical points and make a sign chart. Now when I find my critical points, I get to split up my derivative and set the top equal to 0, set the bottom equal to 0. So in order for the whole first derivative to be equal to 0, that's just the numerator that has to equal 0. In order for the first derivative to be undefined, that's just the denominator has to be equal to 0. So we can solve those separately, which really makes things easier. So if I subtract the 3 and then divide by 10, I get x equals negative 3/10 for that one. Over here, in order for any of this to be 0, just the thing inside the parentheses has to be 0. So this is going to give me x equals negative 1/2. So I have 2 critical points this time. And then I'll make my sign chart. So I've got negative 3/10 and a negative 1/2. And I'm going to recopy my derivative just so I don't have to scroll to look at it. 10x plus 3. All right. So that middle one's going to be tricky, but let's do the easy ones first. Over in this interval, we've got a 0. If I plug in a 0, I'm going to get a positive number on the top, and I'm going to get a positive number to the 1/3 power times 3 is still a positive number on the bottom. So this is all positive. All right, if I plug in something over here like a negative 1 million, I'm going to get a negative on the top. I'm going to get a negative to the 1/3 power, which is still negative, times 3, which is still negative on the bottom. And then let's see what happens in the middle. So this is a negative 3/10 is negative 0.3, and this is negative 0.5. So if I think about a negative 0.4, that'll be my number in the middle interval that I want to plug in. So negative 0.4 times 10 will give me a negative 4 plus 3 gives me a negative. On the bottom, negative 0.4 times 2 gives me negative 0.8. When I add 1, I get a positive. And then I take that to the 1/3 power, it'll still be positive, and I multiply by 3, it'll still be positive. All right, so let's see what happened here. When we're at negative 3/10, the first derivative is 0. Negative 1/2, the first derivative is undefined. Now, that's a little weird, but we're going to go with it because we know that sometimes weird things can happen with radicals. They are not as predictable as polynomials. That's why we spent a whole unit in polynomials just learning the concepts, and now we're going to apply those concepts here with radicals, and we're just going to have to trust the math. This is correct. I checked it in the calculator because I wasn't sure, but this is correct even though it looks weird. In the very end, we'll go graph it in the calculator and see how this makes sense. So the next thing we want to do is answer whatever questions we can about just the first derivative, which is a, b, and c. Where does this function have a horizontal tangent line? Well, horizontal tangent line means a slope of 0, means a derivative of 0. So that is happening here. Wherever the first derivative was equal to 0, that's where you have a horizontal tangent line. It is not the same as critical points because critical points also include places where the derivative is undefined. Those are not horizontal tangent lines. So we want to just take the first half of the critical points, the ones that came from setting the derivative equal to 0. So here's how I would write up that answer. Pause here and read through this if you need to. You're saying where it happens and also how you know that it's happening there. Part B says name the places where the function is increasing and decreasing. And so we're going to say anywhere the first derivative is positive, that's increasing. Anywhere the first derivative is negative, that's decreasing. So we can see it right here on the sign chart. And then we'll write that up. So here's how I would write those up. Again, pause it here if you need to have some time to read through this. The next question asks us to find the relative extrema, and we've got 2 of them. We've got one place where it changes from increasing to decreasing, and we get a max. And we've got another one where it changes from decreasing to increasing. We've got a min. Now we can see it on our sign chart really easily, but the way we justify this is by talking about a sign change in the first derivative and how the first derivative changes sign from positive to negative, from negative to positive. So that's what I'm going to mention when I write up the solution here. So here's how I would write up the answer to the question about local extrema or relative extrema. Those two things mean the same thing. All right, our next two questions have to do with the second derivative. So that's where we've got to go first. We're going to zoom out. We did 4 steps with the first derivative. We're going to do like those same 4 steps with the second derivative. All right, here's where things get a little bit tricky. We're going to take this fraction and rewrite it so it's not a fraction anymore so that we are able to find the next derivative. So this is going to be 10x plus 3 times, then this 3 is going to be a 1/3. So multiplying by a 1/3 is the same as dividing by 3. And then this 2x plus 1 is going to be to the negative 1/3 power. So that negative on the exponent accounts for bringing it up from the denominator. So, I don't know. I think what I want to do is distribute this 1/3 in here. I think instead of having to deal with it, yeah, I think that's what I'm going to do. So I'm going to rewrite the first derivative. You could also just think of it like this. We took this 1/3 and used it to reduce the 10 and then reduce the 3 right there. So this, I'm just going to call this 10/3 x, and then 1/3 times 3 is 1. And then I don't have to deal with that 1/3 anymore. And then times 2x plus 1 to the negative 1/3. All right, so here's my u, here's my b. I'm going to take the derivative of each of those separately. Now that second one required the chain rule. So take a second, maybe pause it here, look over these, make sure you understand everything I did in taking the derivative of those two things. I'm still going to simplify a little bit this v prime. So I'm going to have a negative 2 on top, and this 3, and then the parentheses on the bottom. So that's what I'm going to use for v prime. And actually for v, I'm going to change that one to a fraction also. That's what I'm going to use for v. I'm going to use this. I'm going to use this. And then u and u prime were easy. So I'm going to put those 4 things together in the product rule. All right, so my second derivative is what I'm finding here. I'm going to start with u. And then times v prime. And then a big old plus sign so I can make sure I'm keeping track of which term is which, vu prime. Okay. Actually, this 10/3 does not have to all go in the numerator. You can make it like 10/3, like that. And that'll help me out on my way to getting a common denominator because I want to have a 3 in the denominator. Okie dokie, so let's see what we have now. I don't love having a fraction in the numerator of a fraction, but we'll deal with it. This first term has 3 and then parentheses to the 4/3. I've got a negative 2 that I'm going to distribute into these parentheses. So this will be 20/3 x minus 2. All right, my next term has a 3 in the denominator and then 2x plus 1 to the 1/3 power, and then in the numerator just a 10. Now in order to get a common denominator there, I'm going to need to multiply this by 2x plus 1. Because if that's just a power of 1 and I add my exponents, that'll give me a power of 4/3 like I want. And then it'll match this one over here. So I've got to also multiply this by 2x plus 1, and that will give me a 20, oh, that's not a 20, that will give me a 20x plus 10 as that numerator. All right, so let's see what we have now. This one's kind of messy, but we are empowered young women. We can handle some messy algebra. All right, so I've got my common denominator. And then in the numerator, I've got 20/3 x plus 20x. Let's see, what's 20/3 plus 20? That's 20/3 plus 60/3. So we'll call that 80/3. And I've got a minus 2 and then a plus 10. So minus 8. And then, like I said, I don't love having a fraction inside of a fraction, but remember the next thing we're going to do is set it equal to 0 separately. Like that numerator and the denominator separately get set equal to 0. And so it won't matter so much in the next step. I'll be able to deal with that fraction in the next step. It's not going to trip me up. Okay, I think we're done. All right, this is my second derivative. In the next step, I'm going to find sort of the equivalent of critical points, but we just don't get to call them critical points now. We're going to call them, we're just going to say, find where the second derivative is 0 or undefined. And we do that by setting the numerator and the denominator equal to 0 separately. So for the second derivative to be equal to 0, we want the numerator equal to 0. The numerator was 80/3 x minus 8. So that means 80/3 x is equal to 8, and then I multiply by 3 and divide by 80. Gosh, this is a mess, huh? X equals 24/80. Let's reduce. 8 goes into 24. Maybe I should have reduced this before I multiplied, huh? Cancel that 8, make that a 10. 3/10. All right, so there's my first critical point. My other critical point happens when the second derivative, not critical points. Those are not critical points. Forget I said those. We are just finding the points where the second derivative is 0 undefined. They're not called critical points here when it's the second derivative. So I'm also looking for the place where the second derivative is undefined. So that happens when this denominator is equal to 0. Did I copy that right? Yeah. Okay. This has to be equal to 0, which basically just means 2x plus 1 has to be equal to 0, which means x is negative 1/2. All right. Those are the 2 points that are going to go on my sign chart in my next step. So got a negative 1/2 and a 3/10. I'm kind of wondering if that was supposed to be a negative 3/10. So let me pause and go check my work real quick. Yep, sure was. So sorry about this. but I'm not going to re-record the video. I'm just going to point out my mistake and we will all change it together. So way down here when I was combining like terms, I said 20 thirds x and 20x gave us 80 thirds. We said minus 2 and plus 10. That should have given us plus 8. And so then in this step, we would have had a plus 8, and then this would have been a negative 8 here, and that would have given us negative 3/10. So the reason that sort of like rang some alarm bells is because that's the same numbers we got up here. And they will not always be the same numbers. In fact, with polynomials, they're almost never the same numbers in your first derivative and second derivative. It's kind of just a coincidence that that happened a few times here. All right, so that's a negative 3/10. Okay, so our next job is to look at these three intervals and see if we plug numbers into our second derivative, do we get positives or negatives? We already did this with the first derivative, but the second derivative is a different function, so we got to do it again. All right, in this far left interval, I'm going to think about the number 0. 0 is easy enough. That gives me an 8 on the top, that's positive. It gives me a 1 in here. To the 4 thirds is still 1 times 3, that's positive, so this is all positive. All right, for this interval, I'm going to think about the number negative 1 million or negative 1 gazillion. On the top, I'm going to multiply it by 80 thirds. I don't know what that is, but I know it's negative. And then I'm going to add 8. Since this is a negative, giant negative number, it's definitely bigger than negative 8. So when I add 8, it's still going to be negative. On the bottom, let's see, on the bottom, I'm going to have a negative 2 million. Add 1, I'm still negative. And then here's the important thing. I'm going to raise it to the 4th power. That's going to make it positive. That's going to make anything positive, no matter what I plug in. So I'm going to have a positive, and then I'm going to cube root it. It'll still be positive. Multiply by 3, it'll still be positive. In fact, this denominator is going to be positive no matter what, because anything that I raise to the 4 thirds power is going to end up positive because of that even power. Multiplying it by 3 doesn't change that, so always positive in the denominator. So for this very left interval, a negative over a positive gives me a negative. Now the interval in the middle, that's the one that's going to be a mess. Remember we said negative 0.4 is in there. That's negative 4/10. So let's see if we can figure that out. Now we said the bottom is positive no matter what. I can take negative 4/10, multiply it by 2, add 1. It doesn't even matter if this gives me a positive or a negative in there, because the next thing I'm going to do is take it to the 4th power, and that's going to make it positive no matter what. So I don't really have to think through the bottom. I just have to think through the top. So this is going to be 80 thirds times negative 0.4, so negative 4/10. And then I'm going to add 8. So this is the thing that I got to figure out. I'm going to reduce this by 10. This is going to be negative 32 thirds. Let's see, that's negative 10 and 2 thirds, right? 30 thirds is 10, yeah, negative 10 and 2 thirds, so like negative 10.6 repeating. And then we're going to add the 8 onto that, remember? So when I add 8, that's going to be negative, still negative. So negative in this middle interval as well. All right, so that was kind of a mess. When I write questions for the test, I try to make it easier to do that sign chart piece where you'll be able to come up with an integer that is in this interval. I try to make it so that these numbers are not so close together. So you'll have an integer that you can plug in. It'll be a little easier to do in your head. So what this tells me is I have a function that is concave down for those first 2 intervals and then concave up after that. And that's how I'm going to answer these questions. Question D, I believe, asks about concavity. Let's find it. D, where is it concave up, concave down? We just talked about it, so I'll write that up. And then E is where are the inflection points? And inflection points happen where the concavity changes. So we see we have an inflection point here as well. this negative 1/2 ended up not being an inflection point because the second derivative is negative on both sides of that. It's not a sign change, but the negative 3/10 is an inflection point. So here's how I would write up the answers to the last two questions. Go ahead and pause the video here if you need some time to read through this. And then really what I want you to see is sort of the bigger picture, where we do these 4 steps with the first derivative, 4 steps with the second derivative.